Okay, so our alternative energy is wave energy by Kenzie, Miranda, and Heather. Wave energy is produced when electricity generators are placed on the surface of the ocean. Energy provided is most often used in desalination plants, power plants, and water pumps. Energy output is determined by wave height, wave speed, wavelength, and water density. To date, there are only a handful of experimental wave generator plants in operation around the world.
In physics, a wave is a disturbance or oscillation that travels through space in matter, accompanied by transfer of energy. Wave motion transfers energy from one point to another, often with no permanent displacement of the particles of the medium. That is, with little or no associated mass transport.
Why we should use waves as an energy source. We live near the ocean, so it's easier to get. It's natural and it doesn't destroy our atmosphere.
Why waves aren't a good energy source? Waves are dependent on wind and other waves crashing.
Have you ever ridden a wave in the ocean? Ocean waves travel on the surface of the water. You can see them and you can feel them as you swim through the water. You can also even make your own waves.
That was a video of a buoy, and yeah.
Well, I know there are lots of different prototypes out there right now, and they're testing them all. It is very hopeful for us on the coast here. Okay, we're into nuclear and then biomass. Say what? Yes. This is your show. Let them know who you are from this culminating project. All right, we ready for this? All right. Quiet on the set. Lights, camera.
Alright, I'm Zane.
I'm Shannon.
I'm Kia.
I'm Kayla.
And our energy is wave energy. Mr. Mayor, in our world today, our need for an alternative energy is becoming more and more important. Our supply of fossil fuels is running out and will be depleted on our lifetime. We must look into every other available energy source. One of the best alternative energies is wave energy.
One future solution in the global energy church could be as old as the oceans. Wave energy utilizes a buoy system. Buoys are submerged more than a meter below the water's surface. Inside a cylinder that moves around like a piston-like structure as the buoy bobs with the rise and fall of the waves, the movement drives a generator on the ocean floor producing electricity, which is sent to the shore along the underwater cable. This system is expected to produce 10 megawatts of electricity, enough to power 10,000 homes.
Hello. One of the main benefits is that once a buoy is placed, the energy is free. Another advantage is that it does not produce waste or greenhouse gases. Wave energy needs no fuel, and it can produce electricity and reliability, I think. It can also be maintained at very little expense. The advantages of wave energy are just what the world needs. No harmful waves, no greenhouse gases, and once built, it's free energy, clean energy.
Keep it on the last slide.
There are disadvantages to wave energy. A small installation is expected to cost $5 million per megawatt. Systems that would generate 100 megawatts would cost about $2.3 million per megawatt. That compares to about $1.5 million per megawatt for coal, gas-fired generators. But the fact that fuel for wave power is absolutely free reduces operating cost to the point where it would be competitive with coal or gas-fired generators. Wave energy is also much more cheaper than wind or solar-powered generators according to the company's projections. In addition, ocean power is far more concentrated and predictable than wind or sunlight.
Mr. Mayor, wave energy is the best choice for an alternative energy. The fact that there's no waste or greenhouse gas is incredible. The costs are large, but once installed, the power is free and clean. The ocean with all its secrets holds the key to our future of mankind.
Wave Energy by Lilicito, Sammy Maneri, and me, Iniele Borbonio. How are waves caused? Waves are caused by wind blowing over the surface of the ocean. In many places of the world, the wind blows with enough consistency and force to provide continuous waves along the shoreline. Ocean waves contain tremendous energy potential. Why wave energy? There's not always sun to power solar panels, and there's not always wind to power windmills, but there's always constant wave motion, which is why wave energy would be a good energy resource, and Oregon is potentially a good place to have this.
How is wave energy produced? Wave energy is produced when electricity generators are placed on the surface of the ocean. The energy provided is most often used in desalination plants, power plants, and water pumps. Desalination plants are a plant that remove some amount of salt and other minerals from saline water. Energy that is put out is all determined by the wave speed, wave height, wavelength, and water density. Where would we put these things? Oregon has been identified as the perfect place for wave energy conversion based on the tremendous wave resources. Advantages of wave energy. It's green. Wave energy comes without the warm greenhouse gases. It's renewable. Unlike fossil fuels, it will last longer and will have to be replaced for quite some time. It is consistent power. The wave moves constantly. There is always movement. Low operating cost. Once installed, there isn't as much labor cost unless the device breaks down. Efficient. It doesn't matter which way the waves are moving. Shoreline protection. By capturing the kinetic energy of the tide, it will minimize the wave power crashing on the shoreline, which will minimize shore damage.
We all know energy can come from the wind and the sun, but there's a plentiful renewable resource covering more than 75% of the planet that you might not have thought about: our water. The movement of the ocean's waves, tides, and currents carries energy that can be harnessed and converted into electricity to power our homes, buildings, and cities. The energy available in this moving water is called kinetic energy. Scientists and engineers are learning to capture clean, renewable ocean power using marine and hydrokinetic technologies. Water currents occur naturally all over the planet. Waves crash against coastlines. Tidal currents ebb and flow, and large currents move water all around our oceans. We can tap into each one of these sources to generate electricity. It's estimated that along U.S. coastlines, there is enough energy in waves and tides to meet a significant portion of America's power needs. So, how does it work? That depends on what kind of hydrokinetic power you're trying to capture. But the concept is essentially the same: extracting power from moving water. For example, a buoy can harness harness energy from the vertical rise and fall of ocean waves, as well as back and forth and side-to-side movements. Currents and tides can also spin a turbine in various directions as water moves through an ocean power device, generating electricity. The Energy Department is supporting research on a range of innovative turbine technologies to capture energy from waves, river, and tidal currents. Devices that operate in water have to work under turbulent and harsh conditions. They must be built to withstand strong currents and impacts from debris carried in the water. Of course, they also have to be designed to preserve the integrity of the marine environment. One of the greatest benefits of developing marine energy, or ocean power, is that many of our water resources are right where we need them, near the most populated areas. More than half of all Americans live close to coastlines, where the potential for ocean power is the greatest, and some cities and towns can use power from tidal currents. Marine and hydrokinetic technologies are still a ways off from widespread adoption. But today, dozens of organizations are already working to deploy ocean power systems throughout the world. Marine and hydrokinetic technology, a new wave in harnessing clean, renewable energy from all sorts of water resources, right here at home.
Wind energy and solar energy are good, but they are not as consistent and predictable as wave energy. Whereas when you have like a solar with the light from the sun goes down at nighttime, so you're not getting a full scale of that energy source. When you do it on wind is not consistent because it constantly changes, so you cannot get that constant predictable to get that energy. So whenever it's not windy, you're losing energy. Whereas wave energy is fairly predictable, and you can monitor patterns and changes over the seasons.
Wave energy is like a slinky. When you put a slinky together and release, it sends S-shaped waves.
There are different kinds of wave energy generators. Some are for shallow water, like water turbines, and other for deeper water, like giant buoys.
I don't have the diagram, but on our PowerPoint, there was a giant diagram with different cords going into the ocean connected to the different things. And so you'd have like a giant buoy floating way out in the water, and underneath it would be a bunch of things taking wave patterns and other calculations that they can use to determine how they can use that same patterns of that S-shaped wave to combine it into energy. And then another way they do it is they have in shallower waters turbines, little like square-looking things that go around. And when the water passes through it, they can monitor different patterns and stuff like that. And they can use it to turn the turbines, which is a way to get energy. Another thing they have is they can hook it right up onto a building, a little thing that has tubes going into the water. And it does the same type of thing with the tube, is it spins that tube or pipe, and then that gets energy straight to the home. Some of the facts we found is that on our coast alone, in the United States, we could power over 100 million homes, and that's a lot of power for just water. So if we invested a little bit in that, that could help our power system a lot. If you're interested in joining this quest of water energy source, OSU is a great place in this research field as of today and the past, and it probably will stay to be the best for a while.